Good morning, ladies. Today is Tuesday, January 12th. We are going to be doing lesson 4-8, factoring using difference of two squares. Give me the heads up. This is one of the best factoring methods ever. It's one of my favorites. And the reason why is because it's pretty short and quick and to the point. So today's learning target is I can factor binomial by using the dots method. We're going to learn that dots is called the difference of two squares, just a nice little acronym we can use, an abbreviation. And we're going to use how to use the dots method perfectly. So before we begin, what we're going to do is we're actually going to simplify each of the following using the box method. So we're going to multiply x minus 5 by x plus 5, x minus 2 by x plus 2, and then 2x minus 3 by 2x plus 3. So the first thing I do is I draw my box. So x minus 5 times x plus 5. And we're not going to use FOIL, we're going to use the box method or the area model, whichever way you want to call it. So I do my x minus 5. It doesn't matter where I put it as long as I keep it together. And then my x plus 5. Well, we know x times x is x squared. We know negative 5 times x is negative 5x. 5 times x is 5x. And 5 times negative 5 is a negative 25. Remember, we highlight our diagonal to see our like terms. And if we look, we get x squared. 5x minus 5x is 0x, but we don't write 0x, we write nothing. So in a way, these cancel each other out, and then I just write my minus 25. If you remember in the box method lesson, I said what we can do is we can rewrite everything. So x squared minus 5x plus 5x minus 25. And if you look, I see my cancellation here as well. Minus 5 and positive 5 cancel to make 0. So I would just get left with x squared minus 25. Let's see if that's the case in the other examples as well. So I draw my box. I want to multiply x minus 2 by x plus 2. I'm going to fill in my boxy. I have x minus 2 times x plus 2. I'll do my x minus 2 on the left this time. And now I say to myself, what's x times x? It's x squared. X times 2 is 2x. If you want, you can put the positive. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. Highlight that diagonal. Boom, they cancel each other out again. Negative 2 plus 2 is 0. So when I multiply x minus 2 by x plus 2, I get x squared minus 4 as my final answer. Let's look at this next example where I have 2x minus 3 by 2x plus 3. Fill in your box, draw your box, make it perfect, nice and neat. So 2x minus 3, 2x plus 3. 2x times 2x is 4x to the second power. 2x times negative 3 is a negative 6x. 3 times 2x is 6x, and 3 times negative 3 is a minus 9. If I look, highlight those like terms in your diagonal, they cancel each other out again. So I get 4x squared minus 9 as my final answer. So what do you notice about the answers that you got above? This is the edPuzzle question, so you're going to have to answer this question on edPuzzle. But what I notice is that all of my final answers have two terms. What I notice is all my final answers have two terms. And if I look, they all have a minus sign right in the middle. And then I notice something else. They're all perfect squares. And what I mean by perfect squares is I can take a number and multiply it by itself to get that. So for instance, I can say x times x is x squared. 5 times 5 is 25. X times x is x squared. 2 times 2 is 4. 2 times 2 is 4. X times x is x. 3 times 3 is 9. So all of my answers contain perfect squares as well. Good. So this is a method called dots factoring. We're going to basically start with this and end here. So we want to go backwards. We want to reverse this process. So the problems above are referred to as conjugates. What we mean by conjugates is that they are the exact same except for the connecting operator. So for instance, if you look, these are conjugates because I have a -2 and a +2. I have a -5 and a +5. I have a 2x minus 3 and a 2x plus 3. Those operators right in the middle are different. So that's why we can say they are conjugates. Also, below is a chart of the perfect squares from 1 to 30. You should know up to 15 squared equals 225. I mean, you have a calculator, so if you want, you can do it by that way. But we should know 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. The reason why I'm saying 4 times 4 is because this 2 means that I have 2 4s and I'm multiplying them. So I have 4 times 4, 3 times 3, 2 times 2, 1 times 1. And that's what's giving me this number right here as my perfect square. So 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, and so forth. 11 times 11 is 121, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, 15 times 15 is 225, and then keep on going. People count sheep to go to sleep. I count perfect squares. So the questions to ask yourself if you want to do dots factoring, because we're not going to tell you use dots. We're not going to tell you use AM method. We're not going to tell you any of that. You got to figure it out. That's math. So here's how we approach. These are questions you need to ask yourself, like that you need to think about as you approach these questions. Do I have a GCF? If so, pull it out right now. Do I have 2 terms? Is there a minus sign? And are they both perfect squares? So let's do these examples together. Giving you the heads up, these are examples of perfect squares when it comes to exponents. I mean with variables. So x squared is 1 because x times x. X to the 4th is 1 because x squared times x squared. X to the 6th is 1 because x cubed times x cubed, and so forth. You basically take this term and divide by 2. So 4 divided by 2 is 2 and 2. 6 divided by 2 is 3 and 3. So factor each of the following expressions. So if I look, I have 2 terms, term 1, term 2. You don't need to write 1 and 2. It's sort of annoying and redundant. Do I have a minus? Yes, I do. Let's do difference of 2 squares. Well, here's how I approach. Whenever I have difference of 2 squares factoring, I just do my 2 parentheses right there and there. And I break them apart. I break apart each term and put them in. So how do I break apart an x squared? Well, x times x is x squared, so I'm going to put an x and an x. I'm now going to do a plus and a minus. I'm done with my x squared, so I'm going to cross it out. And I need to ask myself, what times itself is 81? Well, if you look at your chart, 9 makes 81. So I'm going to put a 9 and a 9. So x plus 9 and x minus 9 is your final answer. Let's go on to number 2, 9x squared minus 4. So we go ahead. We've got 2 terms and a minus, and everything is a perfect square. So I do 2 sets of parentheses right now, and I look at each term as I use it. Look at your 9. What makes 9? 3 and 3. So I'm going to put a 3 and a 3 in both sets of parentheses. Now, what makes x? Well, x and x. Done with my x. I've got a minus, so I'm going to do my plus minus. Now, I look at my 4. What makes a 4? 2 and 2. So I'm going to put a 2 and a 2. My final answer is 3x plus 2 times 3x minus 2. Now number 3. I've got a minus. 25 is a perfect square. Y squared is a perfect square. So I just go ahead and do my difference of 2 squares factoring. Do your 2 sets of parentheses. 1, 2. Just like this. I ask myself, what makes 25? Well, I know that 5 and 5 make 25, so I'm going to break apart that 25 to be 5 and 5. What I do, not sure if Miss Townsend does this because I haven't done this with her in a year, but I cross it out when I use it. I have my minus, so I have to have a plus and a minus. And then I have a y squared. Got to break it up or divorce it to be y and y. So my factorization is 5 plus y times 5 minus y. Okay, let's go to these next 3 examples. I have 4x squared minus 81y squared. Those are all perfect squares. They all are. Look at your sheet right here. If I see a 4 and an 81, that's good. These are your perfect squares. If you see these numbers, that's what you want. These are your perfect squares. So 4 and 81 are both perfect squared. X squared and y squared, both perfect squares. Do your parentheses. 1, 2. Take it apart piece by piece. What makes 4? 2 and 2. Cross it out when you use it. What makes x squared? We said it before. I'll move them down here. What makes x squared? X and x. Now I have my minus. I do my plus minus. Ooh, a little too far. Now I ask myself, what makes 81? Well, if I look, 9 and 9. And what makes y squared? Y and y. So I get 2x plus 9y, 2x minus 9y is your final answer. Let's do number 5. Everything's a perfect square. I got my minus. Do your parentheses. 1, 2. What makes 121? If I look, it's an 11. 11 times 11 is 121. So I have 11, 11. Cross it out once you use it. Break apart this x squared. We know it's an x and an x. So I have x, x, plus minus, because of that minus. And then what makes 1? 1 and 1. So I get 11x minus 1 times 11x plus 1. Let's go on to our next example. I've got 1 minus 4x squared. I look, everything's a perfect square. I've got that minus, so I'm going to go ahead and do those 2 sets of parentheses. 1, 1, 2, 2. Take it piece by piece. What makes 1? 1 and 1. Done. What makes my minus? A plus and a minus. Plus, minus. What makes 4? 2 and 2. What makes x squared? X and x. So I get 1 plus 2x, 1 minus 2x. And that's your final answer. However, every time you are asked to factor, it is assumed that you will factor completely. This will typically require you to do a mixture of our factoring techniques. So this is a nice little flowchart my friend Shelly put together. The first thing you do is you always find a GCF. And you have to ask yourself if you have 2 terms or if you have 3 terms. If you have 2 terms, ask yourself, is it a difference of 2 squares? If it's not, you're done. If it is, go ahead, do your 2 sets of parentheses with a plus and a minus. If there's 3 terms, is there a number in front of your x squared? Nope. Then do AM method. So like the diamond. If there is a number, you're going to do slide and divide. We'll learn about slide and divide tomorrow on Zoom. So the first thing we have to ask ourselves, is there a GCF? So if I look at number 1, I have 8n squared minus 18. So I can do my prime factorization of each term. So 2 and 4 make 8, and then 2 and 2 make 4. Highlight those primes. So I can say 8n squared is equal to 2 times 2 times 2, and then 2 n's. 1, 2. Now we got to break apart our 18. What makes 18? 2 and 9. What makes 9? 3 and 3. Boom, boom, boom. So I can say 18 is equal to 2 times 3 times 3. Ask yourself what's in common. Both rows have a 2. So I can say that my GCF is 2. So when I do my leftovers, I have 2. 2 times 2 is 4. N times n is n squared, so I have 4n squared. 3 times 3 is 9, and it's a minus 9. If I look, I can actually break apart this 4n squared minus 9 a little further. Here's how I know. I did my GCF. I have 2 terms. So I'm going to go down this slide. And I'm going to go down and ask myself, is it a difference of 2 squares? It is a difference of 2 squares. So I'm going to have to do a little more factoring. If I look, I can break apart my 4 to be 2 and 2. So I'm going to do 2 sets of parentheses, because they both have that minus and everything's a perfect square. What makes 4? 2 and 2. Done. What makes n squared? N and n. Done. What makes my minus? Well, it's a plus and a minus. And then what makes 9? 3 and 3. This is your final answer. That is factoring completely. It's going to be very, very long. It's going to be very lengthy, but it's going to be 100% correct. So whenever you have a trinomial, here's what I recommend. See that term in front? Divide every single term by it. So I'm going to divide every single term by a 2. So I get 2 divided by 2 is 1, so I get x squared. 8 divided by 2 is 4, so I get a 4x. And 6 divided by 2 is 3, so I get a plus 3. Don't forget, you got to put that term in front to show that you just pulled it out or reverse distributed. So if I look, I have 3 terms. There is no number in front of my x squared, so I'm going to do the AM method and draw my diamond. I want to find 2 numbers that add up to 4 and multiply to 3. So the only numbers that multiply to 3 are 1 and 3 because it's prime. So draw your diamond. 3 goes up top because that's what you want to multiply to. 4 goes down here because that's what you want to add to. I'm going to put that 1 and 3 in. Let's just check. 1 times 3 is 3. 1 plus 3 is 4. So my factors are x plus 1 and x plus 3. But if you remember, there was a 2 in front because of my GCF. This is your final answer. 2 times x plus 1 times x plus 3. All right, we're going to be doing some factoring completely practice over the next few days. If you have any questions, please email myself, Miss Townsend, or Miss Jimenez, and don't forget to do your delta math. Have a great day, ladies.